The year was 1970. The world watched as NASA prepared for another daring mission. Apollo 13 was set to be the third mission to land on the moon. Excitement filled the air. The mission promised new discoveries and stunning images of the lunar surface. The target was the Fra Mauro region. Scientists believed this area held secrets about the moon's formation. The crew trained for months, ready to face the challenges of space travel. Little did they know their courage and ingenuity would be tested in ways they never imagined. The mighty Saturn V rocket roared to life. Apollo 13 embarked on its journey. The crew settled in for what they thought would be a routine mission. They performed systems checks and kept in constant contact with Mission Control in Houston. Everything seemed to be going according to plan. Confidence was high. The astronauts were eager to reach their destination and begin their lunar exploration. Leading the mission was Commander James Lovell. A veteran astronaut, Lovell had already flown to the moon on Apollo 8. Joining him was Command Module pilot John Swigert. Swigert was a last-minute replacement, stepping in when the original pilot, Ken Mattingly, was exposed to measles. Completing the crew was Lunar Module pilot Fred Haise. Haise was responsible for piloting the Lunar Module, which would detach from the Command Module and land on the moon. These three astronauts shared a common goal: to further humanity's understanding of the moon and our place in the cosmos. They underwent rigorous training, spending countless hours in simulators and studying every detail of the mission. Their teamwork was impeccable, each member relying on the expertise of the others. They were a symbol of human ambition and the unwavering spirit of exploration. 55 hours into the mission, disaster struck. The astronauts were performing routine tasks. Suddenly, a loud bang echoed through the spacecraft. Warning lights flashed on the control panel. The astronauts were stunned. Something was terribly wrong. Oxygen levels in one of the service module's oxygen tanks plummeted. The spacecraft shuddered as it lost power. Lovell calmly reported the situation to Mission Control. "Houston, we've had a problem." Those words sent shockwaves through Mission Control. The situation was dire. The command module, the astronauts' only way home, was losing power rapidly. The mission to the moon was immediately aborted. Survival became the top priority. Engineers and scientists worked feverishly to assess the situation and devise a rescue plan. The fate of Apollo 13 hung in the balance. Section 4, a lifeboat for survival. With the command module crippled, the astronauts faced a chilling reality. Their only hope of survival rested in the lunar module Aquarius. Designed for a two-person lunar landing, Aquarius was now a lifeboat for three. Space was cramped, resources were limited, time was running out. The astronauts transferred essential systems from the dying command module to the lunar module. They powered up the Aquarius and prepared for an unexpected journey. They rationed their food and water, knowing that every drop was precious. The temperature inside the lunar module plummeted as they conserved power. The cold was unbearable, but they endured. They knew that their survival depended on their ability to adapt and overcome these challenges. Section 5. The challenge of trajectory. Getting back to Earth was no easy feat. The explosion had knocked Apollo 13 off course. A critical challenge emerged: trajectory correction. The astronauts needed to use the lunar module's engine to slingshot around the moon and put themselves on a trajectory back to Earth. Every calculation had to be precise. Any error could send them hurtling further into space or on a course to burn up in Earth's atmosphere. With limited computing power on board the lunar module, the calculations had to be done on the ground. Teams of engineers at Mission Control worked tirelessly. They used slide rules and early computers, racing against time to develop the correct figures. The astronauts carefully inputted the instructions from Mission Control, relying on their training and the expertise of the team back on Earth. It was a testament to human collaboration, with lives hanging in the balance of every decimal point. Section 6, battling cold and carbon dioxide. As the astronauts huddled inside the cramped lunar module, they faced a new set of challenges. Power conservation became paramount. They shut down non-essential systems, plunging the interior into a frigid darkness. Temperatures dropped to near freezing, testing their physical and mental limits. They shivered uncontrollably, their breath forming icy clouds in the cabin. Another problem arose: carbon dioxide buildup. The lunar module's carbon dioxide filters were designed for 2 people, not 3. The air quality deteriorated rapidly, threatening to poison the astronauts. With ingenuity born of desperation, they improvised. Using materials on board, including duct tape, plastic bags, and spare parts, they created a makeshift adapter. This allowed them to use the command module's larger carbon dioxide filters, saving their lives. Section 7. The Triumphant Return. After a tense journey, the moment of truth arrived. Re-entry. The astronauts jettisoned the crippled service module. They fired the lunar module's engine one last time to refine their trajectory. They then crawled back into the command module, hoping against hope that it would still function. The heat shield, their only protection against the searing heat of atmospheric re-entry, had been subjected to extreme temperatures during the explosion. No one knew for sure if it would hold. The world held its breath as Apollo 13 plunged into Earth's atmosphere. Communication blacked out for agonizing minutes. Then the command module emerged from the fiery re-entry. Its parachutes deploying perfectly, it splashed down safely in the Pacific Ocean. The astronauts were alive. The world erupted in celebration. Apollo 13, though a mission that never landed on the moon, became known as a successful failure. It demonstrated the resilience of the human spirit, the power of teamwork, and the importance of ingenuity in the face of adversity. The lessons learned from Apollo 13 were invaluable. NASA implemented changes to spacecraft design and testing procedures. The agency emerged from the experience stronger and more committed to safety. The mission serves as a timeless reminder that even in the face of overwhelming odds, human courage and ingenuity can overcome any obstacle.